Hello to the Bedini group. Here is my following update. Now, I should notice some new thing which I added to my circuit. In this connection, I added a power switch on, switch off. It's a switch which disconnect this line from my primary battery to the coil. Then I added to my small 24 milliampere lamp, I added a 1 PC speaker. I done this to show you what actually happening when my system running. Alright, now let's look at our voltmeters. We have here one voltmeter. Okay, I will show you before I started my system. So my power switch in position off, I switch it to the on. Okay, now you see in this voltmeter the voltage of my start battery, and here you see the voltage of my charging battery. Okay, I will put it like so. Now I do some small movement of the wheel. Okay, one moment please. Okay, now its process is started. Now I don't use, in my circuit I do not use variable resistor. I will explain it later why I don't use it right now. So if you look again at the Bedini circuit, you will see that I am not using any variable resistor in this connection. Now I should point you hear this sound, the sound coming from the PC speaker, which is here, and you see how the wheel spins. It spins very fast, and now it's almost stabilized. It's running very stable currently. I should point that in my last try to measure amperage of my start and charging battery, I had some nasty bugs. My bulb gone broke, and I changed to a new parts of my circuit, but the parts are always the same. One diode number 1N4007, second diode 1N4001, and transistor 2N3055. Okay, notify. The wheel spins very fast, and for me it's very exciting, because in the past I had always did not so very strong spinning of the wheel. I mean, it was continuously but not so strong like currently now. So I will stop this, try to stop. Okay, I will stop the wheel once again. Okay, and I just do some little movement of the wheel, and I will shut up, and you will listen to the PC speaker. Okay, I think you see that the wheel spinning at always the speed of the wheel increasing. So I would like to know why it's increasing, the wheel, or the speed of the wheel increasing. I think it's a very interesting observation, which I want to that you see it too. Okay, I stop the wheel, and now I will start to measure the amperage of my start battery. I stop the wheel. I stop my wheel, and now I will connect. I disconnect, first of all, safety first. Disconnect my circuit. Now I connect my amperage meter to the system. Moment please. Okay, if here, okay, and I will show you what I connected before I start the system once again. Alright, that should do it. Okay. Alright, so here is my amperage meter. Okay, I check once again my connection. Okay, that's right. That's actually good connection which I have done. Okay, checking, double checking. All right, now I will point. Okay, you don't see it. Did not see it. I will point you to the amperage meter. Just a little. Just take a little time. A little while. All right. Okay. I will try to do it carefully. Okay. Right. Now you see here my amperage meter. It's measuring the amperage of my start battery. And now I start the process. I'm powering my circuit and I move the wheel. Now you see the amperage of my start battery. When the wheels, it take a little bit time to increase the speed of the wheel, and now you will see how much amperage in my circuit current I use. So it's a current of my start battery which I have in the circuit. Okay, I think it's stabilized, and you see it's clearly 0.26, and remember, I do not use in my circuit the variable resistor. I want to show you how the system works without any adjusting of resistance, but I see clearly that adjusting of resistance can make this system much better. Okay, I think this is a speed, optimal speed of wheel and the amperage of my state battery. Okay, I stop my wheel. So at the optimal capacity of my circuit, I have the current usage in amperes 0.28. Okay, now I stop the wheel. Disconnect the circuit. Safety first, that should be very important thing by all experiments. Okay, now I disconnect my measuring device. Yes, I disconnected it. Now I move it away. Right. Okay, I connect the power switch. Right. Now I connect my amperage meter to the power line which is going to the charging battery, and I will show you that is here exactly. I will connect my amperage meter to the charging battery where you have the plus, to this line. So I connect my amperage meter. The amperage meter is here for your view. I have the plus. I need the plus. Alright. Here is the plus. Here is the plus. Disconnect from charging battery. Connect to my system, to my amperage meter. Okay. Alright. And then connect back to the plus of the charging battery. That should do it. Alright. So, okay. Now I connected my amperage meter. Yes, it's connected. Okay, I connected my amperage meter once again to this line, and I will measure the current in this line when the system is running. I power my circuit and then move the wheel. Well, I see clearly that the wheel is increasing, the speed of wheel is increasing, and the amperage of the current which is going to the charging battery currently 0.0201. Now the wheel spinning a lot faster. Now I think it's at the optimal capacity, so it's optimal score of the wheel, speed of the wheel I want to say. It's optimal speed of the wheel. The amperage usage which you are see from the current which going to the charging battery is currently 0.0102, and it's I think most of people who done such experiments show always the voltage, but nobody shows the current drawing from start and charging battery, and